Nitrogen. Imagine waking up one morning and feeling that the air around you has changed. It feels thicker and heavier with every breath. The sky has a slightly deeper tone of blue, and the wind carries an odd weight. Nothing looks wrong, yet the whole world feels different. In this version of Earth, the amount of nitrogen in the atmosphere has doubled. The air now presses harder on everything. Winds move with more force, and storms grow stronger as energy flows through the denser air. Beneath the surface, the change is even greater. The same gas that once kept life steady now quietly becomes its greatest disruptor. Excess nitrogen in soil leads to eutrophication. Soil bacteria begin working faster than ever, releasing compounds that flow into rivers and lakes. Algae spreads, oxygen in the water falls, and balance collapses into chaos. And there's no simple way to turn it back. Oxygen. At first, nothing seems unusual. The air feels cleaner. Breathing feels almost too easy, like standing on a mountain with endless fresh wind. Plants grow faster, fires burn brighter, and your body feels more awake than ever. But the beauty hides a danger waiting to unfold. With oxygen doubled, every spark becomes a potential disaster. Forests that once resisted flames now ignite from the smallest heat. Metal corrodes faster, and even human cells age more quickly under the higher oxidation rate. The world glows with too much energy, too much life, and too little balance. Insects grow larger as oxygen fuels their bodies. That's why they grew massive during the Carboniferous era. Wildfires sweep through continents faster than they can be contained. The same element that once gave us breath now turns the entire planet into a slow-burning furnace. Argon. Among all the gases in our air, argon is the quietest. It does nothing, reacts with almost nothing, and simply exists. Argon currently makes up about 0.93% of our atmosphere. Even doubling it wouldn't harm life, but it would change how heat escapes into space. The extra argon would push other gases slightly out of balance. Flames would burn weaker, since argon dilutes oxygen in the air. Sound would travel softer and muffled, giving the world a strange calm, like the hush of snowfall. Even your own voice would seem faint, as if spoken through dense fog. Over time, cooling systems and engines would struggle because argon traps heat differently than nitrogen. No dramatic destruction, no glowing skies, just a heavy stillness the world would never quite notice. Carbon dioxide. At first, doubling carbon dioxide would make the world seem almost welcoming. Well, at least for photosynthetic organisms. Crops would grow faster, forests would thicken, and the air itself would feel heavier but harmless. Yet everything has a price. This new abundance hides a slow and irreversible turn. More carbon dioxide means more heat trapped in the atmosphere. Oceans would absorb part of it as they already do, turning slightly acidic, dissolving coral reefs, and silencing entire marine ecosystems. As the temperature goes up, the ice at the poles would retreat farther each year. Within a lifetime, coastlines would redraw themselves. Deserts would expand, storms would feed on extra energy, and the planet's rhythm would grow unstable. The Earth wouldn't burn instantly, it would simply stop cooling down. Actually, we've already begun to see previews of this scenario. Neon. Neon is the artist of the atmosphere. It's rare, silent, and invisible until light passes through it. Definitely the quiet spectator of the atmosphere. Doubling its amount wouldn't make the air glow like cyberpunk city signboards, but its presence would subtly shift how light behaves. Sunsets would appear slightly richer, the reds and oranges bending differently through the thicker neon layer. It doesn't trap heat or fuel life. With twice as much in the air, nothing burns differently, nothing breathes harder. Sound would fade faster, barely noticeable to human ears, as its concentration would still be very low relatively. Helium. The gas that makes balloons rise would turn Earth's air ever so slightly lighter. Sounds would shift in pitch, just enough for trained ears to catch. Weather patterns would drift subtly. Warm air would rise faster, forming taller clouds and thinner upper winds. Aircraft would climb more easily but lose some lift at lower speeds. The balance between pressure and temperature would wobble in ways only meteorologists could trace. Helium doesn't react or burn, but it escapes easily. Over time, this excess would quietly drift away into space. That's why it is extracted from natural gas, not the air. Methane. Methane traps heat far more efficiently than carbon dioxide, which is why livestock are often said to play a major role in global warming. So, deep in the atmosphere, Earth begins to warm silently faster than ever before. Polar ice would melt at accelerating speed. Wetlands would release even more methane as they thaw, feeding a vicious cycle that fuels itself. In the tropics, rising heat would push rainfall patterns off balance, turning fertile lands into dust and deserts into storm zones. Wildfires would ignite more easily, and the scent of smoke would hang in the air longer. Nitrous oxide. It's odorless, colorless, and non-flammable. However, it supports combustion to the same extent as oxygen. For this reason, nitrous oxide systems were popular in racing and performance tuning. Nitrous oxide is a mild anesthetic. When it is inhaled, it leads to a state of euphoria, explaining its nickname, laughing gas. If it doubled, the air would still feel light, and the sky would stay blue. However, this gas traps heat hundreds of times more effectively than carbon dioxide. Its rise would push Earth's climate into overdrive. Its molecules can linger in the air for over a century, amplifying its long-term damage. Fields would first grow greener as plants absorb the warmth, but soon droughts would follow. Rain cycles would twist, and lightning storms would become more common as the atmosphere holds more energy. Above, nitrous oxide would start tearing at the ozone layer, letting more ultraviolet light reach the ground. The same gas that makes people laugh in hospitals would make our planet cry. Hydrogen. It loves to react. In the presence of oxygen, it creates water vapor, releasing bursts of heat. So, doubling it would mean more clouds forming, more humidity in the air, and unpredictable rainfall across entire regions. Thunderstorms would carry extra energy, and lightning would become more frequent. Ozone. It's an irritating pale blue gas composed of 3 oxygen atoms, which is explosive and toxic, even at low concentrations. If ozone levels doubled, the sky would glow with a deeper shade of blue, sunlight would lose some of its bite, and the air would carry a faint, crisp scent after every breeze. You're likely familiar with it, the same sharp scent you notice around photocopiers or large printers. As these machines work, oxygen molecules in the air are converted into ozone, creating this distinctive smell. Too much ozone near the ground is toxic. Breathing would sting slightly, lungs would tighten, and plants would begin to wither at their edges. High in the stratosphere, the thicker ozone shield would block more ultraviolet radiation, cooling the upper atmosphere but disturbing weather below. At ground level, ozone acts as a pollutant. High above, it guards life, safer from the UV rays but harsher to breathe. Sulfur dioxide. It is a colorless gas with a pungent odor. Short-term exposures to it can harm the human respiratory system and make breathing difficult. Sulfur dioxide in the air comes mainly from activities such as volcanic eruptions, the burning of coal and oil at power plants, or copper smelting. If it doubled, sunlight would grow dimmer. The air would scatter light differently, painting the sky with a faint gray filter. Much of the atmosphere on Jupiter's moon Io is made of this gas, and Earth's sky would probably look somewhat similar to the colors seen there. At first, the world would cool slightly, a brief pause in ongoing global warming, but it would not last. The gas that cooled the planet would start to poison it at the same time. Volcanic eruptions like Mount Pinatubo in 1991 temporarily cooled Earth by 0.5 degrees Celsius, but at a toxic cost. Sulfur dioxide reflects sunlight back into space, but when mixed with water vapor in the atmosphere, it forms sulfuric acid. Rain would turn acidic, corroding metals, burning leaves, and bleaching soil life. Chlorofluorocarbons. These synthetic gases are stable and silent, drifting upward for years before they break apart under sunlight. But once they do, chlorine atoms escape, and they attack ozone molecules like rust eating through metal. At first, nothing on the ground seems different, but months later, ultraviolet radiation grows stronger, sunburns come faster, crops weaken, and ocean plankton, the base of all marine life, begins to die off. Some of us still remember. We've already seen a glimpse of this scenario before. The uncontrolled use of chlorofluorocarbons once caused severe thinning in the ozone layer, leading to dangerous effects in everyday life. By the late 1980s, countries came together under the Montreal Protocol and banned chlorofluorocarbons worldwide. If you liked this video, don't forget to subscribe. I'll see you in the next video.